Okay, welcome back. Hope you have a nice break. Are there any questions? Before break, we did actually, it is a trend. Okay, so this white hat, I can also write down T. Trend component. Okay, so now students suggest do the second order with SPSS. So I'm going to copy this data. Into SPSS, so copy, go to SPSS file, new, data, and paste. Okay. Let me see. Copy and paste. So this number is registration. I need that one, 6.577. Okay, I need 3 decimals for the registration. Okay, so I'm going to go to the variable view. This is my registration. And I need more decimals, maybe 4 decimals. Okay, so this is my data. Okay, now I'm going to do the regression, analyze, regression, and then curve estimation. Curve estimation. So dependent variable is registration. Okay, and I want quadratic and delete linear. Select quadratic, and also I want to display ANOVA table. Okay. And independent variable is actually this variable here. I should change the name, but never mind. I can use this as independent variable, but I'd rather maybe create a variable. It is a 1, 2, 3, 4. Okay, so I may want to copy this variable here, time series, copy, and paste it here. Okay, so 1, 2, 3 until 33. Then I change this variable. I don't need decimals. And this is my time t. Time t. So I have time t is independent variable. Registration dependent variable. And then I go to analyze, regression, curve estimation. Registration is dependent. T is, registration T is independent. And I need quadratic. I also need ANOVA table. Click OK button. So you get this output. Okay, so this is the quadratic model. You have this coefficient. It is the same value as we get from SPSS. You can, based on these 3 values, to write down an equation. Okay, so that is this one. Okay, we did that one, quadratic equation. Okay. And we also did this one. Any questions? Okay, next. This is example 5.2. 5.2 in the textbook. Okay, so what are we going to do? We want to compute the seasonal index using ratio to moving average method based on this data here. So those are original data. What are we going to do? We want to create seasonal index. Okay, seasonal index. So create a seasonal index. This is the monthly data. It is about company sales. It has 2-year data, 2004 and 2005. The first step, you add the total for the first year. Okay, so add all these numbers together, all these numbers together. The result is 4,869. Next, add this number together. I'll try to use different color. Next, you add this number together. And you get the second number here. So keep on going. You get the 12 months moving total. After that, you do the 2-year moving total. By adding these two numbers together, you get this number. And then try to use different color. Add these two numbers together, you get this number, etc. Okay, and then you use this number, this 9,833 divided by 24. Divided by 24, you get 409. So each number divided by 24, divided by 24, you get the 12 months centered moving average.
Professor, why is it 24? Is it because it's the 2 years?
Yes, 24, because we add this 2-year moving total. This number represents 2-year moving total. So 2 years has 24 months, correct?
Why is this, like, why are these starting at like June and then July? Like the 12-month moving total, like why does it begin at June?
The question is why beginning at the June? Because of the keyword center. We don't want to regular moving average. We want centered moving average. So for 1 year, the center is between June and July. So that's why it is here. We need centered moving average. This method demand using the center moving average. Okay.
Okay, thank you.
Thank you for asking. Any other questions? Okay, once you get 12 months centered moving average, and then you use the original number. Let's delete some annotation. So we are here. We get this 12 months moving average. And this is for July. So you use the number for July, original number, 247, divide 409, you get 0.6. So how do you get 0.6? 247 divide 409. And the next one, how do you get 0.83? You use 343 divide 413.2. And those numbers are your seasonal index. So 0.6 is the seasonal index for July. 0.83 is the seasonal index for August. okay? And then it haven't finished yet. So once you get this preliminary seasonal index, our textbook suggests use the median, use the median, and then do the adjustment. Okay, so the median value for July, because using this method, you can create many index for July. This is 0.6. It is just index for July for year 2004. So if you have, suppose you also have data for year 2000, 2001, 2002, until maybe 2006, you can use this method to create index for July, okay? So for July, the index for 2004, 2003, 2004. For 2004 is 0.6. Use the same method, create July for index for July for 2000. Okay, so for example, our textbook gives you example, it is 0.63, and for 2001, it is 0.94. For 2002, it is 0.598. Okay, so those are the index for July across different years. And all these numbers, you pick a median. Why you pick a median, not average? You want to avoid a number too small, too big. Okay, so you pick a median number. And that median number, the result is 0.651. That is for July. And then use the same method for all other months, for August, September, October, etc. Okay. Once you get this median, you have January, February, etc., December. So this is July. For July, you get 0.654. The January, it is the number is in table 5-3 in the textbook. January, it is 1.2. July, 0.6. December is 1.2, etc. Okay, so you add all these numbers together and you get a number 11.948. Okay, but because it is indexed, that should add together equal to 12. And to do that, you need to do a multiplier. You use 12 divided by 11.948. The result is multiplier. PLIER, multiplier. And this number is 1.04004. Okay. And then once you get this multiplier, you use January 1.273 multiply 1.004. That is your index for January. For July, the index 0.651 times 1.004. And you get the index for July. Okay. Any questions? And this is the implementation using the Excel. I did it in the Excel. I gave you the original number here. So this is, you see the months. Okay. So I can show you the Excel. how to calculate using Excel. Yeah, this is this one here. So I'm just going to copy this data. So which one is given? Those are the given data, 2-year data. Okay, the first number 518. Okay, so I'm going to delete all the let me see. Sales. So those are the other questions. So I'm going to delete all this number. I want to show you from the scratch how to carry out the calculation in Excel. All right. So first, you can put the result here. Okay. You want to add 12 months total. So you do equal sum, opening bracket, from B2 until B13. That is 12 months moving total. Okay, so that is first step. So you get 4,869, and then you copy down this data. I'll delete all the data. You copy down this data. Why I stopped at this number here? Because you are doing 12 months total. If you keep on going further, it will not accurate. For example, this number 5868 is the sum of all these numbers. Okay, so this is our last number. You cannot go to the next one. Okay, so after you do this, you do 2-year moving total. Okay, so what you do, you add these two numbers together. The result is a 2-year moving total. Okay, so after that, you copy down the formula up to here. Okay, you can't go to the next. I have to delete this one, okay, because the next is not 2-year total. After you do this, and you then divide all this number by 24. So this number divide 24. You get monthly centered moving average. Okay. And then you copy down. So these are monthly moving average. And then to get the index, you use original number divide monthly moving average. And then you copy down. So you get the index. This index is for July, and this one is for August, etc. Okay.
Professor, can you
Yes.
show how you got the index again? Sorry.
Okay, the index, you use original number 447 divided by monthly centered moving average 409. I will show you the formula. BH over EH. Okay. Any other questions? Okay. So you get this, and also PowerPoint slide give you the formula. See, those are the formula I created. And I also did demonstration. Okay. All right, so next example, we are going to use this index to do the decomposition. Those are the formula, okay? I'm going to use example to illustrate the decomposition for customary sales, okay? Decomposition. Okay, this is the data. This is the sales data, original data. Based on original data, how do I decompose this data so that it has the trend component? Okay, has the trend. And it has a seasonal, trend seasonal. And also cyclical, and irregular. How do I get those 4 components? Okay, so first I'll do one by one. In order to get other, we also need those help. We also need those item help. So I'm going to do item by item. So imagine this is the sales data. All these data are original data. How do I get this T? Trend. T represents trend. To get a trend, you use regression. Okay, so use sales as the variable Y, and then create this time T. It is series number. And you can get an equation. Create linear regression equation. So I'm going to show you the procedure. Okay, this is the data. Yes. So this is the original data. See? How do I get T, trend component? So you need sales. You also need let me see. You also need a T. I'm going to create a variable T. 1, 2. The trend component, it is actually linear regression equation. That's the reason the beginning part of this lecture, we started with regression equation, right? Okay, so how do I get T, the trend? You go to data analysis, regression. I will delete X and Y. So Y is my sales. Here, sales. These are my Y. X is my T, time T. Output, I will maybe put into maybe T4. Output here. Okay. Click OK button. All right. So this is my equation based on these two numbers. Okay. Looks like the number is not. Let me double check my number here. 28. Yes, it is 28. Those two numbers are a little bit different from the textbook, page 181. I want to find out why. Maybe some of this number, maybe some of those numbers are not right. It is just slight difference. Okay. So once you get this number, how do you get T? T, the trend, equal to B0. Or maybe just write down. So this number is B0, this is B1. So B0 plus B1T. That is my trend component. Okay. And so for, I want to double check this data. My Excel. So I'm going to copy the data in Excel to verify because my equation result has a different number than the textbook. So what I'm going to do, I'm going to copy this data, maybe copy this whole data. Into SPSS. And then the first variable is my T. The last variable I will call sales. So sales T. Okay, now I'm going to create equation. Regression and linear. Sales is my Y, T is my X independent variable. And then I click OK button. So I get this value here. So this number agree with my number. So I get, I'll write this down. I will in then this number agree with the Excel number. Okay, but they are different from the textbook number. I will find out why. Okay, so our Excel number is correct. Okay, those two numbers are correct. But they are different from, maybe textbook use the mini tab or SAS. Okay, so anyway, I will explain the principle here. It is just slight difference. So once you get this equation, and how do you get the number for each T? Remember in the component, we need this T. And how do you get, for example, this number? Okay, so first, you identify equation for this T. Okay, and in our textbook, maybe, so our textbook equation T equal to, I need, yeah, this is the T from textbook. Our equation get different method. We get I will copy my answer. We got 253.74 plus 1.28 T. This is we get from Excel. The textbook gave us 261 is the intercept, 0.759 is the slope. Okay, so there is a discrepancy here. Once you get, suppose you use textbook equation, how do you get 262? T equal to 1. When T equal to 1, you get T equal to 262. And when T equal to 2, T plus T equal to 2, you get 262, etc., etc. So I hope you understand the component. Is it predicted by using regression? No, regression is just part of the prediction process. We need 4 components to make prediction. One is T, trend, seasonal, cyclical, irregular. We just do the 4th component now, T. T is the trend. Okay. Any other questions? We want to use 4 components to make prediction, not just T. Okay, 4. T, S, C, I. So we just need T. Okay. Next, we are going to do SCI. How do I do SCI? Okay. So to do the SCI, you use, remember when you use the additive, multiplicative model, y equal to trend times seasonal times cyclical times irregular. This is y. Okay, has 4 components, multiplicative model. Multiplicative model. Now you want to do SCI, do a little bit algebra. You get SCI equal to y over t. Y over t is SCI. Do you agree? Okay, now let's explain. How do you get 0.888? You use y, 232, that is y. T is 262. So 232 divide 262, you get 0.888. Divide, you get this number. Okay. So once you get this SCI, next you want to get a seasonal. Okay, seasonal index. Okay. This seasonal index, remember we just did how to calculate index. Use the same method. You can calculate index for the original data. Okay, so this is a 0.78 is the seasonal index for this, for quarter 1. By the way, this is quarter data. So seasonal index for quarter 1 is 0.78. Seasonal index for quarter 2, 1.016, based on centered moving average. Okay, so you got a seasonal index. And then you need TCL, trend times T times I. Okay, you need TCI. Okay, so return back to original equation. So y equal to T S C I. Now you want TCI. So use y over s, you get TCI. How do you get TCI? Use y over S. So for example, Y is 232.7, S is 0.78. So 232.7 divided by 0.78, you get TCI. Okay, you get TCI. And next, we need to get CI. Okay, CI. Return back to original equation. You want to get CI. You use Y divided by bracket T times S, you get CI. So CI equal to Y divided by TS. There are some other ways to get CI, but this CI you can get from this equation. Y over T times S. So let's do this. How do you get 1.139? You use Y 232.7 divide bracket T times S. So T is 262, S is 0.78. You get CI. Okay. And now for C, cycling effect, C, cycling effect. How did you get S? S is a seasonal indexed. Using different data set, we just did the example how to calculate seasonal index. Okay. I can show you how to calculate this for quarterly data if time permit. Okay. All right, so where we are, we calculated CI. How do I calculate C? C, we use 3-period moving average. So for example, how do I get 1.118? Using this three moving average, three number, do the average, you get 1.11, no, you get C, 3-period moving average. Not for this number, 3-period moving average for CI here. So do the 3-period moving average for CI, you get C. Okay, so for the first number, 1.118, you do the average of these three numbers, you get 1.118. C, 3 years moving average. Okay, and finally, how do you get the irregularity? You use CI divided by C, you get I, this last formula here. So CI, this number divided by C, you get I. For example, how do you get 1.036? You use 1.159 divided by 1.118, you get 1.036. Okay. So any questions for decomposition? This is a multiplicative decomposition. Okay, so we decompose original data based on original data Y equal to trend times S times C times I. C is the seasonal. Usually it's with the index, seasonal index.
Professor,
Yes.
I just have a question regarding my Excel. So in the last example for number 5.2, I inputted all the formulas and I was following along and it switched it to compatibility mode. Do you know how to like switch it back to like where I get all the functions and stuff like that? Because now it's just showing me like an equation like fx insert function at the top. Like that's it.
You just see the equation?
No, all I have is like an option to put an equation in at the top. Like my Excel switched to compatibility mode when I inputted these like formulas in. Like I don't have the options on like a home, an insert, a page layout, formulas, data, review.
Oh, that probably you need to install Excel on your local computer, not use Excel from the cloud, from the Office website.
No, I do have it. It just happened for this. I'm not on the website. It just happened on this data because it switches when like it sees that you're using some formula, so then it switches to a formula mode. I was just wondering if you know how to like switch it back. If not, don't worry about it. I'll just figure it out later. But
Yeah, anyone know this compatibility mode? I never heard about that. Can you share your computer? Maybe we.
yeah, one moment.
No.
You just need to disable not screen sharing because it says you have disabled it.
Okay, let me see. Give me 1 second. New share. So I need to find that button. Stop share. You are sharing. Okay, I stop sharing. Now you can share your computer.
I still can't. It's you disabled it. So
I disabled it.
yeah.
Oh, can you remember your name?
Tamara.
Tomorrow. Okay. Let me see if I click this button.
It's just it's my last name at Ryerson.
Is this you? Okay, I guess this is a TSNIGOUR.
Yes.
Okay, so I'll try to make co-host, but maybe you know what? Can we solve this toward the end? I'm afraid if I give you the host, I cannot get it back to affect the lecture.
No worries. Do the lecture. I'm completely sorry. I just was.
Yeah, after the lecture, okay, toward the end of lecture, okay?
Perfect. Thank you so much.
Okay, so I'm going to share my computer. Share. Again. Okay, so what we have done so far, we did the decomposition here. Okay, we use multiplicative. The reason we use multiplicative instead of additive is when we plug in this data, create a scatter plot line chart, we found variance are increased over the time. That's why we use multiplicative. If the variance is constant, you can use additive decomposition. Okay. All right, so that is our decomposition. Any questions? And this slide shows you how to get the index. Remember, the data is quarterly data. Those are original data. It is quarterly data. Okay. And to get this is the result of index. For quarter 1, it is 0.76. For quarter 2, 1.01, quarter 3, 1.12, quarter 4, 1.1. Okay, let me double check. That is quarter 1 as 0.78. Yeah. Okay, how do you get a seasonal index for this data? Okay. Let me see how many. Okay. This is the point I'm going to turn to. I already did example, calculate the seasonal data for monthly data. And now you have seasonal data. Seasonal data, how do you compute the index for quarter, for each quarter? So I'm going to go to, hope I have this data. Yes, it is this data here. Let me double check. Okay, so I'm going to maybe copy, oops, copy this, undo it. Try to move my screen. Okay, first you do the average. Let me see. Maybe let me explain this chart first. Okay. Into G columns. First, you do the average of G2 to G5. So G2, G3, G4, G5, do the average of these four numbers because they are quarterly data. Okay. After you do the average plus the average of these four data. These four. And you so do two average. The first average is the first number until the fourth number. The second average from second number, move it down, do the average. And then do the average of those two results. It is here. Okay. So I'm going to show you in Excel here. Okay. Okay, so I'm going to show you the, try to. Okay. So equal, do two average, add together, divided by 2. So the first average is AVER AVER, average of these four numbers. 1, 2, yeah. Okay, this is one average. Closing, oops, see my mouse not working well. So these four numbers, closing bracket, and plus AVER, average of these four numbers. Okay, average of these four numbers, closing bracket, divided by 2. Okay, this way you create a centered moving average, quarterly centered moving average. So add two average together, divided by 2. Okay. So you get this 282. Okay. So after that, you use original number divide the number you just get. Okay, to create an index. And then you copy down until you copy down these two formulas. Okay. So after that, this is the preliminary index for quarter 3. 1.09 is the unadjusted index for quarter 3. 1.08 is the unadjusted index for quarter 4. Okay. So after you do that, you need to do the average of, remember this is the index, unadjusted index for, just want to make bigger. So this number is unadjusted number for index for quarter 3. What other index for quarter 3? And also this number is also the quarter 3 indexed. And this number, quarter 3 index. And then you do the average of all the number I highlighted. Okay. Or do the average of all index for quarter 3. So quarter 3 here. Quarter 3 here. Average the one I highlighted. That is quarter 3. Okay, so continue doing this. Okay. So the result, so equal to AVER AG average of this number, comma, this number, is this comma? Did I type in comma or? Okay. Comma. And this number, comma. This number, comma. Then which number? This number, comma. This number, comma. And this number. Okay. So you did the average. Let me double check my number. Okay. After that, you copy down the formula. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and you get the index for other quarters, and then you add them all. And then you are going to create a multiplier. If you add them all, it is not 4. 4, you should be 4. Okay. And then you use 4. You create a multiplier. Use number 4 divided by this number. This number, it is absolute cell reference because this number will be fixed. Every number here in each column will be divided by 3.96. You get multiplier. Okay. And then this is the multiplier. And then you use this number times multiplier. You get final index. This number times multiplier. And you get, this is index for quarter 3, index for quarter 2, quarter 4, and then quarter 1, quarter 2. Okay, so this how you calculate seasonal index. Okay, seasonal index. I showed you the procedure. Also, the formula is listed on the slide. Okay. All right, shall we take a break? Back at 8, maybe 35, 10 minutes break. Okay, maybe 36, 10 minutes break. It is 8:26. I'm going to see what is the any questions. Thank you for helping each other for the Excel part. Okay, I'm going to stop recording. When I come back, I'll stop.